Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aida binti Muhammad Lutfi. My matric number is 117240. First of all, I want to take this opportunity to thank to Dr. Azira for allowing me to present my radiation safety report and for all the guidelines throughout this semester. Today, I would like to present my report on the radiation protection and safety. So, first of all, my background study. Radiation protection is very important in medicine industry, whether for radiologists or reactor research. Not long after the discovery of ionizing radiation, it's become clear that exposure to high doses of such radiation was harmful to human health. None of this was more noticeable than during the atomic bombing of Hiroshima and Nagasaki during the Second World War, when radiation sickness, genetic mutation, and much more concern over the biological effect of radiation affected thousands of those who survived the initial exposure. This effort developed in the ALARA, which is as low as reasonably achievable protocol, which eventually become adopted as a gold standard of nuclear safety. The essential concept that all radiographers are required to implement is the use of technique and the provision of protection devices to minimize the radiation to patient and staff. All safety regulation and practice were common to other large-scale research laboratories or high-power industrial facilities will be observed. However, to define radiation safety and compliance with the regulation and the protection workers against radiation overexposed, first, we need to know how to calculate the attenuation of radiation sources. Moreover, the thickness of shielding needed for protection, especially for gamma radiation, need to be classified. In addition, it is important to be able to identify what are the legal personnel monitoring dosimetry or risk assessment used for radiation. The objective of this study are: first, radiation safety aim to provide humans with an appropriate protection level without excessively restricting the beneficial activity that result in radioactive exposure. Second, radiation protection is designed to prevent harmful deterministic effects. Third, to reduce the risk of stochastic effects arising, for example, cancer and hereditary effects. The significance of this report study is to encourage and promote the active involvement of employer and worker organization in development of international standard of occupational radiation protection and in the implementation of the occupational radiation standard, thus improving the radiation safety information for physician and patient for a better protection. In this report, the method to achieve this objective include the measurement beam limitation, justification for radiation exposure, shielding with appropriate distance, and optimum radiographic exposure factor. All these methods basically were divided into three phases. Phase 1, the count rate of detected gamma ray was measured as a function of mass thickness of various observers that are placed between the source and the detector. Then, phase 2, attenuation data for commonly used shielding material was acquired from National Institute of Standards EXCOM database at attenuation coefficient. Here, the most appropriate shielding material for a given source of ionizing radiation was selected, which is a gamma radiation. The basic principles of gamma radiation interaction with metal was studied. The third phase is four methods such as the particle counter, the ionizing chamber, the photographic film, and the thermoluminescent detector were studied to measure radiation dose rate, and the quantity of radioactive material present. So here the result that had been obtained. First, attenuation is gradually decreased in energy as the X-ray passing through the absorbing materials, for example flesh or tissues. The actual quantity that was interested in when we were talking about the attenuation is what we call the intensity of the X-ray. The intensity is defined as power per unit cross-sectional area, which now the power is measured in watt and the area was measured in meter per square. And the SI unit for intensity is watt per meter square. The intensity of X-ray will decrease exponentially as it enters and passes through the tissue. So this is the equation indicate where exponential decay factor, which is e to the power of minus. Minus here denote that it's exponential decay. And then the quantity mu is the absorption coefficient, which is depend on the type of absorbing material, and is the thickness of material or how much the depth it penetrates. So you can see from this graph 1, air does not really absorb X-ray at all, but as soon as it enters the body and its soft tissues such as flesh, the intensity will decrease in these fashions. First, in bone, the intensity of X-ray will decrease much quicker with distance. From here, we can see the difference between soft tissue and bone clearly. A plot of the total mass attenuation coefficient versus gamma energy for some common shielding material is provided in this figure 1. Higher atomic number elements such as lead, bismuth, And tungsten has much higher mass absorption coefficient and should lower energy gamma radiation and X-ray better than lower atomic weight elements such as iron and aluminium. There are ionizing radiation measurement devices we include in this study. Particle counters are designed to detect the movement of single particle through the defined volume. Gas field counter collect the ionization produced by the radiation as it passes through the gas and amplify it to produce an audible pulse or other signal. Counters are used to determine radioactivity by measuring the number of particles emitted by the radioactive material in a given time. Ionizing chamber consists of pair of charged electrodes that collect ion formed within their respective electric fields. Ionization chamber can measure dose and dose rate because they provide an indirect representation of energy deposited in the chamber. Photographic film of exposure to ionizing radiation is an indicator of the presence of radioactivity. Film is often used to determining personal exposure and making the dose measurement for the record of dose accumulated over a period of time or for which permanent record is required. Thermoluminescent detector (TLD) are crystal that can be excited to a high electronic energy level by ionizing radiation. TLD systems are replacing photographic film because they are more sensitive and consistent. Okay, now let's move on to the discussion. Radiation protection should be designed, construct and operate to the high level of safety in order to meet the expectation of its user, other personnel, and to meet all regulatory requirements. There are such passive safety in the fundamental safety principle which the radiation produced in the target station contained within 3 confinement barriers. The design is such that when the accelerator stops, the production of neutron will also stop. Residual heat can be removed from the tungsten target through passive cooling, so no active cooling system is required. Radiation protection and safety will be key aspect of any operations and carefully monitored by the regulatory authorities. And now, finally, this report concludes that attenuation or shielding of gamma radiation is an important component of radiation. The attenuation of gamma radiation can be achieved using a wide range of material. Understanding the basic principle involved in the physical interaction of gamma radiation with matter that lead to gamma attenuation can help in choice of shielding for a given application. Those attenuation properties of shielding material can be estimated to within 10 to 40% using mass attenuation coefficient. These efforts will give confidence to the radiotherapy, which will bring the benefit to the patient. The protection can be optimized by adequate dose in the target and decreasing of the dose up to reasonably achievable level in other tissues. As I bring my presentation to a close, I once again want to thank you for allowing me to present my report, and I wish you all a blessed day. Any question or improvement suggestion from Dr. and friends are much anticipated. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.